Hello friends, in this video we will discuss about this Google certification Generative AI Leader. This certification is helpful for business leaders as well as application developers. In this video we will discuss about first section of this certification, which is fundamentals of generative AI. This section covers 30% questions of your exam. This video you can say is a revisional note that you can listen before going for the exam. This will revise all the concepts that are required for the exam. Let's start. The first topic is artificial intelligence. Artificial intelligence is a software that performs tasks that require human intelligence. For example, decision making task or speech recognition. Machine learning is subset of artificial intelligence. Here the primary focus is on learning from the data or examples. Here we basically collect the raw data, train using the algo, and then predict on the new data. Deep learning is subset of machine learning. Here we use artificial neural networks, and here we not only analyze the data, we actually learn from the data. We synthesize the data, and deep learning is the engine behind generative AI and foundational models that we will discuss soon in this video. Now, to understand the machine learning lifecycle, we have 5 stages. First is data ingestion. Here we collect the data from raw sources. If we are using Google, then Google PubSub, cloud storage, or MySQL we can use here. Then the next stage is data preparation. Here we clean the data, format the data, label the data. All this we do in this data preparation stage. Google product like BigQuery data analysis is helpful here. Then next stage is model training. We train the algorithm with the prepared data. Tool we can use is Vertex AI platform. Next stage is model deployment. Here we make the model available to the users. And the final stage is model monitoring. In model monitoring, we monitor the performance of the model as well as maintain this model. To understand this with spam filter model example, let's see. So in spam filter model, data ingestion stage is the raw mails, thousands of raw mails that we have. Then data preparation stage is labeling them spam or not spam, which we do in data preparation stage. Then model training stages, we are providing these thousands of labeled data to the algo in order to understand what we call as spam mail and what we call as not spam mail. And model deployment is deploying this spam filter model on email platform, and model monitoring is monitoring this model's performance metrics and maintaining this model with new data as the spam evolves. So this is about machine learning lifecycle. So in machine learning, data is very crucial. So data must have these 5 characters for successful machine learning outcome. First is accurate, second is complete, third is consistent, fourth is relevant to what you are doing, and fifth is representing the real world. With this characteristic, we say that data is good. Good data means better output. Junk data means junk output. So data basically is of 2 types. One is structured data, one is unstructured data. Structured data means labeled data, like having images categorized as cat, dog, horse. These tags are there with the images. So this we can say structured data. Unstructured data is having raw images with no tags. We can say unlabeled data. So in machine learning, we have 3 types of learning. First is supervised learning, where we use labeled data. Labeling the data can be expensive, but more labeling means better learning. And is here tag is learn from the past to predict the future. This kind of learning is helpful in application where we want to predict, say for loan approval prediction software. We use customers' bank statement, credit score in order to decide whether loan is approved to him or not. So with this labeled data, software is taking predicting that loan should be approved or not. Fraud detection also supervised learning example is, and email classification as we discussed, spam, non-spam emails that we can do using this labeled data in supervised learning. Unsupervised learning is a learning where goal is to find hidden patterns and also group similar items together. Here we use unlabeled data. Here tag is, here is a mess, can you make sense of it? Applications that use unsupervised learning can be where we want discovery or grouping, say grouping customers based upon their purchase history or anomaly detection. Next type of learning is reinforcement learning. Here goal is to make decision to maximize a cumulative reward. Here we learn by doing and maximize the reward. Here we do some action, then we get feedback, and if feedback is positive, good. If feedback is a penalty or it is negative, we adjust the strategy and again do the work. So this kind of pattern is helpful in decision making in dynamic environment, like for example in product recommendation. So we suggest a product to a customer. If he likes it, that means our algo is doing good, and if customer dislike it, we take this feedback, approve our model, and similarly start providing more further product recommendation to him. So in supervised learning, data type is labeled, whereas in unsupervised learning it is unlabeled, and in reinforcement learning there is no pre-existing data. Goal of supervised learning is predicting the outcomes, unsupervised learning is finding the patterns, and reinforcement learning is maximizing the rewards. Supervised learning example is spam filter, unsupervised learning is customer grouping, and reinforcement learning is product recommender. Now the next section is generative AI. Generative AI is a subset of machine learning that focuses on creating a new content. Generative AI uses foundational models that we will discuss in few minutes. So in generative AI, we basically create articles, mail, images, videos, summarize long documents, discover insights from data, and automate documentation, repetitive tasks, etc. So we basically do create, summarize, discover, and automate. How can generative AI be so, like, can do so many of things? The reason behind is that it not only analyze the data, it actually synthesize the data. Whereas traditional AI models are trained on specific tasks like self-driven car, can answer about things related to driving of car, but it cannot answer you other scenarios. Whereas in generative AI we use foundational model which is trained on vast amount of diverse data across different domains. So it's a general purpose AI, and it can be flexible. So this is how generative AI is so powerful. And to train a foundational model, we usually require high computational power, specialized hardware, and massive infrastructure. Foundation model examples are LLMs or Imagine or Gemini. So LLM is large language model, which is a text foundational model trained on diverse amount of text data. They are designed to understand, summarize, and generate human-like language by recognizing complex patterns in the task. At their core, LLM functions by predicting the next token in a given sequence based upon the context provided. So foundational model is trained on diverse amount of multimodal data, whereas LLM is trained on diverse amount of text data. There is a temperature knob in LLMs which controls the behavior of the model. So the temperature value can be between 0 to 1. If it is lower, like 0.1 and 0.2, that means model will give the output as more predictable, more accurate. If this temperature value is high, like zero point 0.7 or zero point 0.9, that means the model will be more creative. And say for example, if there is a sentence that we give LLM to answer, the sentence is the cat sat on the dash. So there are three words: mat, table, or moon, where mat is having maximum probability that cat is sitting on the mat, table is having medium priority, and moon is having less priority. So if my temperature knob is lower value, that means high probability token will be picked. So if here mat is the token or word where we are having the maximum probability, so LLM will pick this word mat, the cat sat on the mat. If my temperature is high, that means my model will pick the word or token which is having lowest probability. So here, if my temperature is high, the answer will be the cat sat on the moon. So basically, for scenarios where I want accuracy, I will use a low temperature value, and scenarios where I want creativity, like writing poems, I will use high temperature in LLM. This diffusion model is also a foundational model. Here, this model is used to create image, audio, video. How it works, it basically creates a random noise, then asks user to give feedback or prompts, and accordingly it refine this noise to make a realistic art. So say for example, I start with a random noise, then the prompt comes of make a image of astronaut riding a horse, and then this noise is refined iteratively, step by step, to emerge as a structured realistic image where astronaut is riding a horse. So these kind of models are used for creating realistic pictures from text, producing AI generated videos from still images, etc. Now comes Gemini. Gemini is a multi-model foundational model. Foundational model we know which is trained on large amount of vast data. Multi-model means Gemini is trained on text, video, audio, code, different types of data types. Also, Gemini can answer you if you ask Gemini a question which includes text or image or video or combination of them, and then you are asking Gemini to give the output in video form only. That also Gemini can do because it is multi-model powerhouse. Gemini is for general purpose AI, whereas there are specialist toolkits or expert tools we have that Google offers. First is for creating images from text. There is a tool which is called Imagine. It is also a foundational model. It is used for cases like creating social media content, marketing visuals, etc. Then there is another type of foundational model which is called Chirp. It is used for creating audio from the text, speech recognition. This model is trained on large scale multilingual audio dataset. This model is used in real-time transcription, voice assistants, etc. Next type of model is VO. VO is used for creating videos from the text or creating videos from the audio. This is a video generation foundational model. It is used in cases like storytelling, etc. Apart from these AI models, there is one open source AI model as well provided by Google, which is Gemma. Gemma is a lightweight foundational model openly released to help the AI community innovate and build responsible AI. So Gemma family includes Gemma, which is a general purpose AI model trained on diverse data. Then there is a code Gemma, which is used for coding. It is helpful in programming. Then there is a Polygamma, which is designed for vision language tasks. For example, you upload an image, then ask questions from that image that Polygamma can answer easily. Now we discussed so many AI models. Now It's about discussing prompting versus engineering. Prompt is just a simple instruction to AI model that we are giving, that we call it as prompt. Whereas prompt engineering is a creative prompt that help AI understand your requirements better and give you more accurate response. So if we say prompting is a general request, then prompt engineering is a tailored to objective request. So prompting goal is just for interaction, whereas prompt engineering goal is to maximize performance accuracy of the model. So in prompting, I casually ask anything to the model, whereas in prompt engineering, I have steps of instructions, personas through which I will ask the AI model to answer. Now the last topic of this video is understanding the layer of generative AI, understanding the generative AI architecture. So we have basically 5 layers. First layer is infrastructure layer. So here we have hardware, storage and networking. Google actually provides TensorFlow software toolkit as well as tensor processing units GPUs specially designed for training AI models. So basically Google is here providing you the hardware part, then the cloud part, which comes under this infrastructure layer. Then there comes the model layer, which is the core intelligence. Here we train a model with vast amount of data, and example of this model layer is Gemini, Imagine, Chirp, these models. Platform layer is the workbench to build, manage and deploy the models. It offers APIs, data management capabilities and deployment tools. Example is Vertex AI. Agent is goal oriented. It needs to complete some task, and to complete them it uses inputs, tools available to it, and also Gen AI models. And then the top layer is the application layer, which is the user interface, which can be a chatbot, mobile app, website. So there on the top is the application layer, which is the application, mobile app or website. Then inside it are agents, which are giving you solving some task, and these agents are using AI models through platform layer in this AI infrastructure. So this is the core architecture of generative AI. I hope this video is very helpful before you are going for the exam. Uh, Please do comment your feedback. I try to explain all the topics that are listed on official Google website, study material that we have on Google website. So there is this section which is listing these topics which I covered in this presentation. So this presentation is also helpful for me. When I go for the exam, I definitely revisit this. You can treat it as your revision notes. Thank you for watching. In the next video, I will cover section 2 of this exam. Thank you for watching. Good day. Bye.